This is where we left off in the previous video. We have to find the area of the triangle DEF. The only thing we have been given is the coordinates of the three vertices. We constructed three perpendiculars from the three vertices onto the x-axis and got the coordinates of points G as x2, 0, the coordinates of H as x1, 0 and the coordinates of I as x3, 0. Let's zoom out and find the area of triangle DEF. If you look closely, you can see that the area of triangle DEF is equal to the area of the trapezium EGHD, this region, plus the area of trapezium DHIF minus the area of this big trapezium EGIF. You have to understand the figure well. Let me repeat it. The area of this triangle is the sum of the areas of these two trapeziums minus the area of this big trapezium. So with the given coordinates, if we are able to find the area of each of these three figures, we can find the area of this triangle. And guess what? All the three figures are trapeziums. So we have to know the formula for the areas of a trapezium. It is half multiplied by the sum of parallel sides multiplied by its height. So let's go a bit slow and look at each trapezium individually to find the area of triangle DEF. First, we look at trapezium EGHD. The parallel sides of this trapezium are EG and DH and the height is GH. Its area will be half multiplied by EG plus DH multiplied by GH. Similarly, the area of trapezium DHIF will be half multiplied by DH plus FI multiplied by HI. DH and FI are the sum of parallel sides and HI is the height. For this big trapezium, EG and FI are the parallel sides and GI is the height, which makes its area half multiplied by EG plus FI multiplied by GI. What did we just achieve? Look at all the segments on the right-hand side. All the segments you see now are either parallel to the x-axis or to the y-axis. We have avoided the lines DE, EF and FD, which may or may not be parallel to any of the axes. Calculating the length of each segment is very simple. If we look at line EG, we can say that its length is y2 minus 0, which is y2. Similarly, length of DH and FI will be y1 and y3 respectively. Segments GH, HI and GI lie on the x-axis. So length of segment GH will be x1 minus x2. Length of HI will be x3 minus x1. And length of GI will be x3 minus x2. Substituting these values on the right-hand side, this is what we get. Looks complicated, but trust me, it's really simple. We just have to write down each value systematically. Half is a common factor to all the terms. So taking half outside, we use the distributive property to expand the brackets inside. Multiplying y2 with this, we get x1 y2 minus x2 y2. And after multiplying y1 with this, we get x1 y1 minus x2 y1. Solving each of the brackets, we finally arrive at something like this. Then we need to check if we can cancel out any like terms. We can cancel out x2 y2, x1 y1 and x3 y3. This looks a bit cluttered and we need to represent it in a better way. From these two terms, we take x1 common and write it as x1 multiplied by y2 minus y3. Taking x2 common from these two terms, we write it as x2 multiplied by y3 minus y1. And taking x3 common from these two terms, we write it as x3 multiplied by y1 minus y2. This formula will give you the area of the triangle in terms of the coordinates of its vertices. This proof isn't difficult. It's just a bit calculation intensive. All you need to know is that to find the area of this triangle, we need to add the area of the two trapeziums and subtract the area of this one trapezium from the sum.